Remember when we tried to define what work was? It wasn't washing the dishes, writing a letter to someone, or brushing your teeth. It was our evil friend that was doing the actual work by throwing the huge boulder towards the city by using force and displacement. Now, why did we come back to this example? Well, you'll understand soon enough. Let's say that a superhero tries to save the city by defeating the monster. He activates his superhuman strength and then punches the monster and quickly flies off in the air due to that powerful punch. Our superhero saves the day. Okay, now let's see where our topic comes into the picture. When do you think power is applied? Is it when he activates his superhuman strength, or is it when he punches the monster? If punching the monster was your answer, then yes, you are correct. Power in this situation is measured by the amount of work done in a given time period. Since the superhero was strong, he managed to complete his task of punching the monster in a less amount of time. Power, by definition, is the rate of doing work or transfer of energy. If we were to make this into a formula, it'll be power equals work done over time taken, or W divided by T. Keep in mind that the unit of power is watt. No, I wasn't asking you what the unit of power is. I'm telling you that the unit of power is watt. So, with that, if we were to produce 1 watt of work, it means we have done work at the rate of 1 joule per second. So, formula-wise, it is 1 watt equals to 1 joule per second, or 1 joule second raised to minus 1. Let's see how we can implement this into a practical example. The work done by a man on pushing a box a certain distance is 60 joules and time taken is 30 seconds. What is the rate of work done by the man? We've been provided with the values of work done and the time, which is 60 joules and 30 seconds respectively. The formula for the rate of work done or power is equal to work done over time taken, or in this case, 60 joules divided by 30 seconds. Calculate this and you get 2 joules per second or 2 watts. Another exercise which I want you to try. The rate of doing work or power is equal to work done per unit time or W divided by T. But we are not given the value of work done here, so we need to find the value using the formula of work. Do you remember what the formula for work is? Work done equals to force times the displacement, which is F times S. From our given information, force equals 40 Newton and displacement equals 8 meters. So work done equals to 40 Newton times 8 meters. This is equal to 320 Newton meters or 320 joules. Now that we know what the value for work done is, along with the value of time, let's apply it into the formula for power. Power equals 320 joules divided by 10 seconds, which equals to 32 joules per second or 32 watts. So here is the thing. Joules is actually a unit that is deemed too small when it is being measured for energy used in commercial and industrial uses or factories with huge electrical appliances. There's a unit for such big appliances, and that is kilowatt hour. If a machine like a bulldozer is using 1000 joules of energy each second and is being used consistently for an hour, then the bulldozer is consuming 1 kilowatt hour of energy. A kilo is nothing but 1000. Electrical energy used in an entire month, if you know, is measured in terms of units. In this case, 1 unit is equivalent to 1 kilowatt hour. Let's do an exercise. We are given the value of power in the exercise, which is 200 watts, and the value of time, that is 4 hours. But wait, there is something missing here. Can you guess what? The unit of power is watt, of course, but since we're talking about a big appliance here, which is the candy maker machine, The unit of power would be kilowatt hour. So we need to change the watt here into kilowatt. Go back 3 decimals from 200 and we get 0.2 kilowatts. Now let's find out the energy consumed. Energy equals to power times the time taken, which is 0.2 kilowatt times 4 hours, and we have 0.8 kilowatts hour as the answer. So 0.8 kilowatt hour is the energy consumed by the machine in one day. We can also say that the energy used is 0.8 units.